Hi everyone, in this video we're going to look at how to use the TI-84 graphical calculator to find the mean and standard deviation for data. We're going to take two IB questions to have a look at how to achieve this. So in the first question, we've got some discrete data. We've got exercising times in whole numbers of hours, 2, 3, 4, 5, and the number of students that have done that. So we've essentially got the exercising time and the frequencies, the number of times students have responded to having exercised that amount of time. So we start by typing in the data into our TI-84. So the way that you do that is you click on Stat, and then we choose Edit. So choose this one here, and we're going to put the initial data into list 1 and the frequencies into list 2. So for our set of data, we had a 2, a 3, a 4, and then a 5. And then going on to the next list, we're going to put our frequencies in. So that's going to be 5, 1, 4, and 3. So we've now put in the data on the left-hand side, the frequencies on the right-hand side. To now work out the mean and the standard deviation, we're going to go back into the Stat menu. We're going to go onto Calc to do some calculations, so we'll go across the right. This is one variable statistic because only one thing is being measured for this particular set of data. So one variable statistics, click on Enter again. We need to tell it where to look for that data. So for the actual data itself, it was list 1. If we needed to choose that, you can see that list 1 is written down here, so you can press second and then press that button there to get list 1. The frequencies, this is important to remember to make sure that you tell the calculator where to look for the frequencies, which is in list 2. Again, I could press second and list 2 for that, and then I go on to calculate. And once it does that, it then basically works out a load of statistics. I may not need all of them. For me particularly, I'm interested in the top one, X with a line over the top that's set as X bar, and that is the mean for this set of data. So the mean for this set of data is going to be 3.38. This is what you get if you add all the data together and so on. We can ignore those. For us, the standard deviation that we're going to want to use is this symbol here. This is the Greek letter sigma. So this is the standard deviation for a population, 1.21. That's the value that we are going to take. The other ones that might be useful at times, if we go over a little bit further, is Q1, that's the lower quartile, Med is the median, and Q3 is the upper quartile. So those might be useful in other situations. Okay, so we can then go back and just write down those answers, giving our answer to 3 significant figures. In this second example, we're looking at the weights of mangoes at a particular farm. And we're going to estimate the mean and standard deviation again. Because this data is continuous, whereas before it was discrete, it means that each of the data categories is grouped as opposed to actually knowing the bits of data like we did in the previous example. So we know, for example, in the first column that we have 4 mangoes that weighed between 100 grams and 200 grams, but we've lost the information about what they actually weighed exactly. As a result, when we're trying to work out the mean and the standard deviation, we have to estimate what their weights would be by taking the midpoints of each category. So for example, if a mango weighs between 100 grams and 200 grams, we would estimate that each of those mangoes weighed 150 grams. We would go for the midpoint of each of those categories. For the next column, we would estimate that if the mangoes weighed between 200 and 300 grams, that they actually weighed 250 grams. So start by finding the midpoints of each category, write those numbers down in your working because there's going to be marks allocated for writing down those midpoints, and then those are the numbers that we will be typing into our graphical calculator to work out the estimate for the mean and the standard deviation. The process is exactly the same as we did before. We're going to type the information into list 1 and list 2, the midpoints into list 1, the frequencies into list 2, and then we're going to let the GDC do all of the number crunching for us. So typing in the data, we go into Stat now, we click on Calculations, 1 variable statistics. Again, list 1 is where our data is, list 2 is where our frequencies are, so we make sure that that's written down correctly. Then we can click on Calculate, and we can see that the mean would be 385 to 3 significant figures, and the standard deviation would be 115 to 3 significant figures as well. Just to check that you've put things in correctly, one little trick that you can use is just checking that n is the right value. N is the number of pieces of data. So if we think of our data here, if we added all the frequencies together, we would get a value of 49, so we know that we've typed in the right amount of data here.